All right, let's try it. Okay, first of all, algebraic expressions, guys. Do you know the difference between an expression and an equation? The terminology here.
They are spelled different. What else? Hopefully they sound familiar.
Uh, when I was in school, my math teachers never told me like the difference between expressions and equations. And when I finally found out, it really helped me out. You know? Okay, equations is pretty easy because there's a or an equal sign there, right? X equals 2. Okay, that's an equation. With an equation, your ultimate goal is to isolate the variable, right? You want x equals something or y equals something. The variable that you're solving for has to equal something. So your ultimate goal here is to isolate the variable. All right. Now, with an expression, guess what? There's no equal sign, right? So you're not going to be looking for that x equals a number, or it could be anything really, like a fraction, or when we get into isolating y's, get into messy expressions, okay? But there's no equal sign, so you're not looking to solve it. Okay? What you want to do with expressions is just to make sure they're simplified, they're in their simplest forms, right? So you want to make sure that you can, like combining like terms, adding the numbers together, multiplying. So you're simplifying the expression. Okay? So you're not going to be isolating. You don't necessarily have to isolate the variable. Okay? You can have a number of terms in your answer, and there's no equal sign. So it always confused me until I actually wasn't until college that um, somebody actually explained the terminology to me. We didn't have those nice terminology when back in the Stone Age. So, all right. So I just wanted to clear that up. Just because it's in the, it's bold in the on the work page here. I'm going to hide this. So don't come up on the video. All right. So the first thing we would learn about here, or review, is powers. Well, what's a power? Well, it's got a base. In this case, my base is 2, and powers have exponents. And this exponent is a 5. Together, 2 to the 5th is called power, where 2 is the base, 5 is the exponent. Now, what that means is 2 is being multiplied by itself 5 times. So if I do 2 times 2, which is 8 times 2, 16 times 2, 32. So this equals 32. And guess what I just did? I did they gave me 2 to the 5th, and I wrote 32. I simplified that expression because there's no equal sign here. That's all I did. All right. By the way, if there's no exponent, if I just have a number, say I have the number 8, is that a power? Is there an exponent there? There's always a 1, right? There's always a 1. So if you really want to get technical, every number is a power. But because, I mean, we can't sit there and say, oh, well, I want 8 to the first cents. We say 8 cents. We just don't use that power of one in real life. Okay? But technically, every number's a power. All right. Then we get into algebra. Okay. Now, when we put an x, here's some more terminology for you. When we put an x or a y, or you have a variable or a letter, it could be any symbol. You can have a triangle equal something. It doesn't have to be an x or a y. It's representing a value. Okay, that's a definition of a variable. It's it is a number. We just don't know what the value is. And that's why we use an x or a y. All right. And when students start algebra, when everybody starts algebra, because we all do, um, that's the most confusing part about algebra. We're like, well, what is x? Well, we don't know. It represents a value. It could be anything. So, kids, students, and they were never told. We put x's and y's there. We put a variable there because we want like a general expression or equation that works for everything, for every value. Okay, whatever value we put in there, we can solve. So that's what algebra is. It's an abstract thought, really. Okay, so I have variables here, and this is really kind of cool because if you follow PEMDAS, which we'll get to in a minute, um, you really should be. It helps to remember what PEMDAS is when you're simplifying the expressions because you have to do your parentheses first, then you have to do your exponents, and then algebra. You know what undoes exponents is radicals, so it's exponents and radicals, and then you go to multiplication, division, then addition and subtraction. Okay, that's PEMDAS. So the one thing neat about here, we don't have any parentheses, we don't have any exponents or radicals, but we do have multiplication and division. Now, multiplication is an addition, are really kind of the really cool operations in mathematics because they're commutative. You can change the order. Okay? 2 times 3 is the same as 3 times 2. 2 plus 3 is the same as 3 plus 2. It's the only operations that you can switch things around and get the same answer. Can't do it with division, can't do it with subtraction, can't do it, with the other operations in math. So, if you're having trouble, and I know we will get into more complicated problems, but if you're having trouble seeing that there's three x's and two y's here, group them together because they're commutative. We can change order. So I'm going to put my x's together. X times x. Let's see, I got another one here. Times x. And then I'm going to put my y's together. I got a y times y times y. And that kind of helps me see exactly how many x's and y's I have, right? So what's x times x as a power? Well, it's x to the third. X being multiplied to itself 3 times. And the y, well, y is being multiplied by itself twice. So I could go the other way too. I can either simplify 2 to the fifth as 32 or simplify all this expanded numbers and make it exponents. It depends on what people or the directions want you to do. And I say people because it depends on your careers. You're going to have bosses, supervisors tell you do it one way and you're used to doing it another. All right, let's take a look at B. Some more terminology here. What's a number what's a number called being multiplied to a variable? You guys remember? Help you out. Starts with C. O. Coefficient, right? Coefficient is a number right in front of a variable. It's a number being multiplied to the variable. Okay. So that means in this parentheses, I got to follow PEMDAS because I got to do parentheses first. Um, Addition and subtractions last, so I gotta figure out what to do with this parenthesis to help me keep things organized in uh, in these parentheses here because I want to make sure I do everything inside here before I subtract three. That's why when I do these problems, a lot of times I'll put parentheses, or even when we go to evaluate, which is later in the page, I still use parentheses. To this day, I use parentheses. Okay. And we'll get to that later. So I'm going to go ahead, because this is all multiplication, remember it's 6 times n, I'm going to group my sixes, 6 times 6 times 6 times 6, and then my n's. Oh, I'm not going to fit it in here. Times n, times n, times n, times n. Okay. Well, 6 multiplied by itself 4 times. Now, I know a lot of the worksheets and a lot of the tests says no calculator, especially SITs. You're going to have sections that are no calculator. Um, this is way too early in the morning for even me, so I'm going to use a calculator. 6 times 6 times 6 times 6, 1296. So I'm still going to use my parentheses. 1296 n, and then I'm going to bring down my minus 3. Okay, so what's my answer? What's my answer to this problem? Well, 1296 minus 3 is 1293, right? So 1293 n. No, why not? Oh, thank you. Thank you. They're unlike terms, right? I cannot subtract 3 from the 1296. 1296 has an n to it. Okay? This is my answer. This is simplified. This expression is simplified. I cannot combine these two terms. All right,
Familiar now with that?
coming back to you.
Should.
Negative numbers. Watch your PEMDAS. Here I have negative 3 in parentheses. That means I'm taking negative 3, multiplying it by itself 4 times, right? Negative 3 times negative 3 times negative 3 times negative 3. Well, let's do this. Negative 3 times negative 3 is positive 9 times, I'll put parentheses, times negative 3, negative 27 times negative 3. So negative 27 times negative 3. Positive 81. Okay. Negative 3 to the fourth. No parentheses. What's the answer for this one? To follow PEMDAS. What does PEMDAS tell you to do first? Remember that minus sign is like negative 1 times 3, right? That's what that means. So what do I do first here? Exponents, right? Exponents first. Okay, so I have negative 1 times, you could use parentheses, 3 to the fourth. Well, let's see. 3 times 3 is 9. Oh, wait, I did that over here. 81. Now, PEMDAS tells me to do, I did the exponents, Then I do multiplication and division. So negative 1 times 81 is negative 81. So be extremely careful. This is going to, I guarantee I'm going to have at least, well, not so much in this class, but in Algebra 2s, they trick you on the SATs. They put problems like this on the SATs on purpose. I don't know if you guys remember doing. Did you? Yeah, you came in last year and took the SATs. They put these on the test. Did you notice them?
No, I didn't really notice.
Yeah, in the problems, especially the even the calculator problems, they did this to you. They'll include a negative sign, raised to a power, and outside. Because if you put it in the calculator, your calculator is strictly PEMDAS. Okay? If you put on there um, negative 3 to the fourth in parentheses, you get the positive 81. Without parentheses, you get the negative 81. Your calculator is really strict on that PEMDAS. That's how it works. Um, I'll have students because a number of times they won't get the right answer because they forgot to put the parentheses in, or it really is a tricky thing that we math people like to put in there for you. All right. Evaluate. This is where I was talking, or PEMDAS. This is where, we were following PEMDAS up here. You're just going to be doing it here. Okay. Like I said, I like to rewrite everything and I do every step when I'm teaching. Okay. I have to do parentheses first. So I'll put the parentheses in there and then I'll do it off to the side. Let's see. Negative 2 plus 5 is 3. Okay. Nothing more I can do in the parentheses. Go to exponents and radicals. So exponents next. 3 squared. So I got my negative 4. I got my plus 2 parentheses. 3 squared, 9. Multiplication is next. Got my negative 4 plus 2 times 9 is 18. Negative 4 plus 18, 14. You can use calculators on these as long as you put it in exactly like this, and if the directions let you. Again, many times it's going to be cannot use calculator on this problem. Okay, so be careful. Negative 5 squared plus 3, going to do parentheses first. 2 minus 6, negative 4. So I got a negative 1 times 5 squared. So I got to do the exponents first because there's no parentheses around negative 5. 5 squared, 25. Negative 4 squared is a positive 16. Okay. Negative 25. Nothing more to do there. Plus multiplication, 3 times 16, 48. Negative 5 plus 48, 23. A lot of places to make mistakes in something that's relatively looks simple. Fractions, please, before you do the fractions, simplify the top. In fact, be better just to put parentheses around them. Simplify the top first, then do the bottom, then do the division. 5 divided by 5 is 1. Bless you. Bless you. Okay, again, this is where we evaluate. Okay? Evaluate is nothing more than substitute in the given value. Substitute in the given value. Okay. Evaluate the given value when x is negative 2. So I'm going to take that negative 2, wherever there's an x, I'm going to substitute it in. Now, this is a good problem because it's a negative 2. You're definitely, and this is what I was saying before, when you're evaluating, wherever you see that x, put in parentheses, okay, and copy everything else. I do this to my, even today, I do this. Okay? I've done this my whole life because it's so easy to make a mistake. Wherever you see an X, put in your parentheses, especially if you're not using a calculator. Okay? So my X is negative 2. Then start evaluating. Okay? Have to do nothing more to do than the parentheses, so I'm going to uh, do the exponents. Negative 2 squared is my, let's see, positive 4, right? Nothing to do here. There's no exponent for the 2. So I'm going to take my minus 5, multiply it to a minus 2, and that becomes a positive 10. Plus 7. I can multiply this now because there's no more exponents or anything. So it's negative 12 plus 10 plus 7. Now it's addition and subtraction. Go left to right. Positive 5. Okay, we already talked about this. Um, like terms, the 2x and the 4 are not like terms. This is the algebraic term. This is a constant term, obviously, because there's an x in this with this number. By the way, terms, that was another thing that took me a while. What's the difference? Is this a term? How many terms are there? You would, yeah, this was another thing that wasn't clarified to me until after high school, because no high school teacher taught me this. This is one term. A term has to be separated by a plus or a minus. Okay? Has to be separated by a plus or minus. See, there's no plus or minus here, so it's one term. I should put by unlike terms. Okay, unlike terms. Because if you got 2 plus 4, you can combine those, even though it's two terms. The original problem's two terms. It really is one term because you can combine those. These you can't combine, so this is two terms. That was never clear to me until after I was in college. So, like in this problem, we start out with 1, 2, 3, 4 terms, but we can combine like terms, the 3x and the 2x, minus 2x, to get a 1x, and plus 7 plus 8, so plus 15. I end up with two terms. Okay? Again, something that high school teachers seem to just assume that you know. Maybe we thought you learned it in pre-algebra or algebra, and it always kind of mind boggled me.